In our previous videos, we have already discussed about what exactly is a normal random variable and a standard normal random variable. Today, in this video, we'll talk about area under any normal curve. So we all know in general that any normal random variable has a specific mean and a specific standard deviation. So you guys must be thinking that we would require a separate table to calculate the area for each pair of mean and standard deviation, right? But in actual, we don't need any such table. We will use the same table as the area under the standard normal curve or the probabilities for a standard normal random variable. The table that we also discussed in our just last video, we'll be using same table to calculate the area under any normal curve. Now you must be thinking how, since the two random variables are different, right? So basically what exactly we will do is we will express the area under any normal curve in terms of the area under a standard normal curve, right? So in short, we will simply convert, let's just write it down, simply convert or transform normal random variable, let's suppose that is x, into standard normal random variable, that is z. So what we are doing, we'll simply transform our normal random variable to a standard normal random variable. And once this x has been transformed to z, that is normal random variable has been transformed to standard normal random variable, we can easily use the same table as that of the standard normal random variable, right? So how will we do this? First of all, let's just describe a few terms. Normal random variable be expressed as x with mean mu and standard deviation as sigma. Now for this z, that is standard normal random variable, let that be z, where mean is equal to 0, this we all know, and standard deviation is equal to 1. So all we need to do is we need to transform this x to this z, and with the same properties, that is mean is equal to 0 and standard deviation is equal to 1. We need to convert x such that it means becomes 0 and standard deviation becomes 1. So for this, we have this specific way of transforming it, and that is z is equal to x minus mu upon sigma, right? So that is, this z will have mean 0 and standard deviation equal to 1. Also, this converts, basically this formula is converting x to standard units. Whenever we are talking about standard units, we try to say it's about z. We are talking about z, right? This is also z values. So that is basically we are transforming x to standard units, that is z values. Now, how is this mean? How does this particular formula makes the mean 0 and standard deviation 1? About this we'll discuss later in this video itself. But let us discuss one important point. Now let's suppose we are asked to calculate the probability that x lies between x1 and x2. So how will we calculate it? So see simply, if first of all what we will find is we will find z1. z1 is equal to x1 minus mu upon standard deviation. Then we will calculate z2, that is x2 minus mu upon standard deviation. So basically over here, for all the values of x falling between x1 and x2, we will have some specific z1 and z2, and those values will also lie between z1 and z2, right? And we are saying if we have this x1 which has corresponding z1, and we have this x2 which has a corresponding z2, and we are trying to find the probability between x1 and x2, we can simply say that this is equal to the probability that z lies between z1 and z2. What we are saying is that just like x1 and x2, each corresponding values between x1 and x2 have their respective z1s and z2, each have their respective z values between this interval itself. Right? So if let's suppose we have a value x3 that lies between x1 and x2, then z3 will also lie between z1 and z2. Right? Simple. So thus we have reduced the required number of tables, and all we need to work is we need to simply work through this z values or the standard normal distribution table. Now, what did we say? We said this formula that z is equal to x minus mu upon sigma is converting the mean as 0 and standard deviation is equal to 1. We discussed over here that z has mean 0 and standard deviation 1. But how? How did this formula actually help us? See, how did we get these values from this? Simply, let's talk about mean first. So, expected value of z, if you're taking expectation, mean of z means expected value, is equal to expected value of x by sigma minus expected value of mu by sigma. Yes or no? Right? So this is nothing other than 1 by sigma expected value of x minus mu by sigma. Now this is equal to expected value. What is the value of expected value of x? Expected value for x I mean is mu. So this becomes mu upon sigma minus mu upon sigma, and that gives us 0. So this is the reason why the mean of z becomes 0. Now standard deviation. Standard deviation, so what we will do is we will talk about variance over here. We all know that standard deviation is simply a square root of variance, right? So variance of z is equal to variance of x minus mu upon sigma, right? This is also variance of x upon sigma minus variance of mu upon sigma. Now we know this part. Mu upon sigma are constant values, right? It's not a variable. So for a constant value, variance is always 0. So this becomes variance of x upon sigma minus 0. Now sigma is a constant. To take it out, 1 upon sigma square variance of x. So this becomes, what is the variance of x? Variance of x, we all know over here that standard deviation is sigma. So variance over here becomes sigma square. So this becomes sigma square by sigma square, which is equal to 1. And since variance is 1, this indicates standard deviation is also equal to 1. Right? Because it's simply the square root of variance. Clear? So this is the reason when we are saying that we are using this formula in order to convert x into z values, we are getting mean 0 and standard deviation 1. Now let's talk about an example. This example will help us understand how to solve questions in the exams and how is this work, how we are working around, right? Okay. So question says, a project yields an average cash flow of rupees 550 lakhs. Average simply stuck in our mind, it's a mean. And standard deviation cash flow of rupees 110. Calculate the following probabilities assuming the normal distribution. So what we are giving is, so let's just first of all write down what information is given to us and then we'll look upon the parts. Okay. So let x be the random variable that denotes cash flow. Right. So x is simply a random variable that denotes the cash flow, and this x is normally distributed. This x follows normal distribution with mean 550 and standard deviation 110. Please see that these are all basically in rupees, but we are talking in terms of numbers over here. Let me just write down this is denoting. That was hiding it up. 110. Right? So we have got this. Now we have simply written out this. Now we all know we will have to calculate the probability. So probabilities involve converting x to z values. How do we convert it? Z is equal to x minus mu upon sigma. So from here this is equal to x minus Mean, that is 550, upon standard deviation, that is 110. We have this. Let's start with our first part now. Now we are coming up to the question. Cash flow will be more than 675 lakhs. So what we need to find is, we need to find probability that X is greater than 675. Yes or no? Cash flow more than 675, right? So let's convert it into Z. For X is equal to 675, can we say Z is equal to 675 minus 550 upon 110? Yes or no? And this is simply 125 upon 110. Right? So this becomes simply our 1.14. So we are saying for X is equal to 675, Z is equal to 1.14. Now we need to find the probability that Z is greater than 1.14. So how will we find this? Let's draw a sketch. Let's sketch it up. This is our standard normal distribution table, and it's the standard normal curve. Now we know this is the mean 0. Now we know Z is greater than 1.14. 1.14 is here. Z is greater than here. We need to find this black part. How will we find it? So one thing we know very clearly, let's that this entire yellow part, what is this yellow part? This is 0.5, because the area under the standard normal curve towards the right of mean 0 is always half, right? And let's suppose, what if I subtract this region, that is the area that lies between 0 and 1.14 from the 0.5. Can we get this area? Right? Can we get that black shaded area? So I'm saying over here that if we want to find probability that Z is greater than 1.14, can we simply do 0.5 minus probability that Z lies between 0 and 1.14? See, we are subtracting this entire yellow shaded region. We are subtracting this green shaded region, this small green shaded region, from this entire yellow shaded region. That is 0.5 minus probability that Z lies between 0 and 1.14. This will give us this probability, right? So now let's write it down and use the table in order to practice it. Z is greater than 1.14 is equal to 0.5 minus probability that Z lies between 0 and 1.14. This I have simply written it down from here just for your convenience. Now, so this is equal to 0.5 minus, how do we calculate the probability that Z lies between 0 and 1.14? We all know we will search for one place after the decimal. Till that we will search in our rows section, and then we will move towards the column section. So 1.1 is here. Yes. And 1.14 means 1.1 plus 0.04. So 0.04 is here. So in short, we are subtracting this figure. 0.5 minus 0.3729. And this gives us 0.1271. Right? This was easy. Okay. Now, this is the same thing, this is the same question. Cash flow will be less than 450 lakhs, right? So, we need to find the probability that X is less than 450. So, what is this, right? So, first of all, let's just copy down the Z figure over here from here. This was our Z. We'll just copy it out, that Z is equal to X minus 550 upon 110, right? So now for X is equal to 450, what will be the Z now? Z will be 450 minus 550 upon 110 minus 100 upon 110, and this becomes minus 0.91. right? So therefore, what we need to find is, to find the probability x is less than 450, we need to find the probability that z is less than minus 0.91. Now it's always easier for us to sketch it up because the scope of error reduces. With practice, you won't have to actually sketch it up every time, but unless you are not, it's not on your tips, just simply sketch it up. It will hardly take a second, but you won't be able to do any incorrect thing. You will definitely get a correct answer with this. So mean is equal to 0, and let's suppose this is minus 0.91. Now we need to find the probability that z is less than minus 0.91. So basically we need to find this probability, this shaded green shaded region, yes or no. So again, since we know that the area towards the left of 0 is 0.5, so can we say that this entire region, red region, is nothing other than 0.5. Red shaded area is 0.5. Now, what if we subtract this blue region from the red shaded area, this whole 0.5, if I subtract this blue region, will I get this green region? Right? So just by subtracting this blue region from entire 0.5, we'll get the green region. That is the required probability. So this is equal to 0.5 minus probability that z lies between minus 0.91 and 0. So again, we have simply taken this entire region, that is 0.5 minus this blue area, and this will give us this green area, that the probability is less than minus 0.91. Right? Now we know that by symmetry, if I need to find this blue region, we also know, let's suppose this is 0.91. By symmetry, this blue area and this round blue area, both the blue areas are equal by symmetry. So 0.5 minus probability that z lies between 0 and 0.91. This is equal now by symmetry, and we also know this. We have already covered this in our previous videos also. So this becomes probability, let's just write it down again. Z is less than minus 0.91 is equal to 0.5 minus probability that z lies between 0 and 0.91. Now, this is equal to 0.5 minus 0.91. 0.9 is over here and 91 is over here. So this becomes 0.3186. Right? So this becomes 0.5 minus 0.3186, and this gives us the figure 0.1814, and we are done. Right? Okay. Third part. Now again, we'll simply write that this portion. Z is equal to x minus 550, that is mean, upon standard deviation 110. Okay. Now question says, what is the probability that x lies between, that the cash flow will be between 425 and 750 lakhs. Right? We need to find this. Now for both the x's, can we say we need to find the corresponding z values? Yes or no? So for x is equal to 425, z is equal to 425 minus 550 upon 110. Right? And this is equal to minus 1.14. And for x is equal to 750, z is equal to 750 minus 550 upon 110, and this becomes 200 upon 110, that is 1.82. So to find the probability that x lies between 750 and 425, this is equal to the probability that z lies between minus 1.14 and 1.82. So we now just have to calculate these probabilities. So let's just write it down over here. So we need to find the probability that z lies between minus 1.14 and 1.82. Again, same thing, we will sketch it out, that becomes easier. So this is 1.82. This is our mean equal to 0 and this is minus 1.14. So what is this? This is simply equal to the probability that z lies between 0 and minus 1.14 plus the probability that z lies between 0 and 1.82. So we have simply added this region and this horizontal marked region. We have simply added this in order to get this entire blue shaded region. Now for this, we know by symmetry that if this is 0 and this is minus 1.14, then this region will be same as this region. By symmetry, right? Because around 0, the normal curve or the standard normal curve is symmetric. So this becomes, can we simply write it out? This is equal to probability that z lies between 0 and 1.14 plus the probability that z lies between 0 and 1.82. Right? So we have this in the table. 1.14 means over here 1.1 and 0.04 is here 0.3729 plus this probability is lie between 0 and 1.82. So 1.8 is here and 1.82 is here 0.4656. 0.4656. From here we have our total, that is 0.8385. Right? So this is how we find the probabilities for a normal random variable by simply converting into a standard normal random variable. Right? I hope you like this video. Do subscribe this channel for more videos. Thank you.